Sneaky. What you doing, dude? Cutting calories from the soup. Okay. Well, I was told if I don't, they escape at night and get into your closet and make all your clothes smaller. Really sneaky, they're really hard to see. I think you need to watch this next video, right? What's up everyone, my name's Scott, I'm the nutritionist here at Fit for Life. We're going to split this video into 3 parts to make it as simple as possible for you guys to understand. We're going to give you an education on nutrition, how fat is stored and burnt, and how muscle grows, and how different types of foods called macronutrients are used in the body. Let's get into it. Calories and what carbs do. What is a calorie? A calorie is a unit of energy. It's actually a unit of heat, just like a centimetre is a unit of length. It's the energy needed to raise the temperature of 1 ml of water past 1 degree Celsius. We know this as thermogenesis. Now that we understand what a calorie is and not the little gremlins that enter your closet in the middle of the night make all your clothes smaller, let's ask the next question. What are macronutrients? Macronutrients are nutrients that provide calories for energy. Nutrients are substances needed for growth, metabolism, and for other body functions. Since macro means large, macronutrients are needed in large amounts. There are 3 macronutrients: carbohydrates, proteins, and fats. While each of these macronutrients provide calories, the amount of calories that each provide vary. Carbohydrates provide 4 calories, 4 calories per gram. Protein provides 4 calories per gram. Fat actually provides 9 calories per gram. It's a little more dense. This means if you looked at a nutrition label of a product and it says 10 grams of carbohydrate, 0 fat and 0 protein, you would know that this food has about 40 calories per serving. 10 grams of carbs multiplied by 4 calories, 40 calories. Besides carbohydrates, protein and fat, the only other substance that provides calories is alcohol. Alcohol provides 7 calories per gram. Alcohol, however, is not a macronutrient because we don't need it for survival. Well, some people do. Let's face it, how's homeschooling going for you guys? Why do we need carbohydrates? Carbohydrates are the macronutrients that we need in the largest amounts. According to dietary references, 45 to 65% of calories should come from carbohydrates, unless of course you're trying to burn body fat, and we're going to cover that in next week's video for you. We need this amount of carbohydrate because carbohydrates are the body's preferred source of fuel. Carbohydrates are needed for the central nervous system, organs such as kidneys and the brain, and your muscles, including your heart, to function properly. They are turned into glucose in the liver and hold about 3 grams of water for each gram of carbohydrate, hence why your weight fluctuates on the scale so much. All of the tissues and cells in the body can and prefer to use glucose for energy. Carbohydrates can be stored in the muscle and liver as glycogen and later used for energy. Carbs stored in the liver can be used throughout the whole body and all the functions, but carbs stored in the muscles can only be used by the muscles that they're stored in. But what happens when the storage is full? Well, yeah, that's right. It's saved in a reserve tank. You would know these reserve tanks as fat cells. This is how fat is stored in your body. Picture your car's fuel tank once it's full. It'll start filling the reserve tank, and unless you use all of the fuel, you'll never actually use the reserve. The aim for fat loss is to have enough carbs in your body to fuel your body from the liver and keep the muscles relatively empty, forcing your body to use fat as a fuel source during exercise and everyday muscle use. We'll go into this a little bit more further on how fat is burned in the next video. Carbohydrates are also important for intestinal health and waste elimination. Fiber refers to a certain type of carbohydrate that our body cannot digest. These carbohydrates pass through the intestinal tract and help move waste out of the body. Diets that are low in fiber have been shown to cause problems such as constipation, hemorrhoids, and increase the risk of cancers such as colon cancer. Diets high in fiber, however, have been shown to decrease the risk for heart disease, obesity, and help lower blood cholesterol. Foods high in fiber include fruits, veggies, and whole grain products. Mate, so that's as simple as that. That's carbs. They're not as evil as you think. I hope this helps you guys. Comment below any questions you have, and I'll answer them for you as soon as I can. I've added a short graphic at the end of this video to help simplify it just a little bit more for you. In part 2, we're going to look at proteins and fats and how they're burnt and how proteins are used to grow muscle. Don't forget, like, subscribe, hit the notification bell to catch next week's video. Until then, we'll see you next Tuesday.
What is glycogen? To answer this, we're going to start with carbohydrates. When we eat carbs, our body breaks them down into what is called glucose. Glucose is the main source of energy, or fuel, for cells. When the cells are full of fuel, the body takes this extra energy and converts it to glycogen. So glycogen is a form of energy storage in the body. It is estimated that the body stores about 2,000 calories worth of energy as glycogen. It gets stored in mainly two places, in muscles and in the liver. Glycogen that is stored in the liver can be used by other organs and cells in the body. Glycogen that is stored in muscles is not shared, so it is used only by muscle cells. It is estimated that the liver will store about 400 calories of energy, and the muscles will store about 1,600 calories of energy. Now we're going to take a basic look at how this works. Let's say that Jack here is about to eat. His liver glycogen tank is 3/4 full, and his muscle glycogen tank is also 3/4 full. Jack eats his meal, and the carbs are broken down into glucose. Some of this glucose is sent by the liver into the bloodstream to cells throughout his body. The liver takes the extra glucose and converts it to glycogen and stores it for later use, filling up his liver glycogen tank. In between meals, when energy is needed, the liver breaks the glycogen down into glucose and releases it into the bloodstream. As you can see, the glycogen tank starts to empty until Jack eats again. One note here, fat can also be converted to energy to be used, and I'll cover that in another video. The process will be similar in the muscles. Jack's muscle glycogen tank was 3/4 full before his meal. After his meal, the tank is full. In between meals, Jack is moving around, causing his muscle glycogen tank to become depleted until he eats again.